Okay, so this is a long time coming. As I said, I'm going to do the Hess's Law handout, example number 4. Now, this question is a much more complicated question. So in this case, I checked in with Miss Aragona, and in this case, what we're going to expect, most likely, we don't expect you to do a question like this complexity using the enthalpy cycle. You don't have to use enthalpy cycle to solve this problem. Um, but what I'm going to do is I'm going to show both ways to do it. So I'm going to use systems of equation as well as enthalpy cycle. So let me do the system of equation first. Okay. Now, if you read this question, so the enthalpy of combustion of ethylene C2H4 gas, uh, C2H6, and hydrogen are these three different values. So in this case, use these data to calculate the enthalpy of hydrogenation of ethylene. So adding hydrogen to this. So what I've done is I've written all three of these equations. So this one is the first combustion reaction. And so this here will be minus 1390 kilojoules. Now here it says kilojoules per mole, but that's because it's kilojoules for 1 mole of C2H4. Since this is 1 mole already, so I can just say it's kilojoules. Now this one here, C2H6. Now this number here is minus 1550 kilojoules per mole. Now, I kind of just was lazy and I just kept this number here. So I want to keep it as kilojoules per one mole of C2H6. So that's why I have a fraction here, 7/2. Now, however, Jordy, when she was solving this problem, she was following what we normally do. So she didn't keep the fractions. She multiplied the whole entire thing by 2. Then in this case, you will have to multiply this by 2 also. Okay, so it'll be 3,000 and 3,100. Okay, now same thing here. Hydrogen is H2, right? So again, minus 286 kilojoules per mole. So I kept it as 1 mole of this stuff. So it's H2 plus half of oxygen. So these are the three combustion equation and the enthalpy that we're given. This here, hydrogenation of ethylene, is what we're trying to look for, right? So what I'm going to do is we're going to use these systems of equation to find what's the enthalpy of this equation. So let me just remove this background. So in this case, just like what I've done in class, using system of equation, I actually numbered these equations first. So it's just keep things organized. It's much easier if you do that. And then afterwards, I underline the things I want within the system here. So in this case, I want C2H4. So I underline C2H4 here. I want hydrogen. So I underline hydrogen here. I want C2H6. I want C2H6, so I underline these. So these are the three things I want. The rest are I don't want it at all. So step 2, let's manipulate these equations and organize things that we want. So in this case, this one here, C2H4, I want it on the left-hand side of the equation. So in this case, I don't need to do anything. So I just rewrite it. I'm rewriting it just so that it's neat. Because when you're crossing things out left, right, and center, you just want the things neat so you're not making a mistake that way. Yep, so I'm just do that. So that's fine. I'm not doing anything new because this is where it should be. Cross this out. I want hydrogen also on the left. So here, equation 3, hydrogen is also on the left, so don't need to worry about that. Rewrite this here. H2 plus half of oxygen gives me H2O. Again, the number is minus 286 kilojoules. I keep this underlined, and that's it. Okay. Now, number 2, I do want C2H6 on the right-hand side. This is on the left. So in this case, I have to flip this equation around. And in this case, what is minus, it becomes positive. So flip 2 and then minus 1 times, right? So in this case, flip this. What's on the left becomes right. What's on the right becomes left. Underline this here. Now, because I flipped it, the sign also changes. Now it's a plus 1550, right? So at this point, what I'm going to do is I'm going to cancel things out. So in this case, I'm going to cancel things out. 2 carbon dioxide here, 2 carbon dioxide there, that canceled out. Now, let's see. 3 water on the left. There's 1 water plus another water, 2 water. So this is 3 water, canceled out. I have 7 over 2 oxygen, which is 3.5. Oh, look, I have 3.5 on this other side. So this also cancels out. So in this case, what I have left here is C2H4 plus hydrogen gas gives you C2H6. And now my delta H here is really this number plus this number plus this number. So I just add these numbers up. So minus 1390 plus minus 260 plus 1550, which, where's my calculator? Where's my calculator? So much for being organized. All right, so since I can't find it, I'll use the laptop. So minus 1390 minus 286 plus 1550. Oh, look, it's minus 126 kilojoules. So in this case, the answer for the enthalpy of hydrogenation of this would be minus 126. Now, I kept the unit as kilojoules. It can also be kilojoules per mole since we're having 1 mole of this stuff here right now. But if you look at the cognitive textbook and the handouts, it's not really that much difference. So there's not like a particular format or unit that delta H has to be. It really depends on the question. And the question here didn't quite say what is the calculation of this has to be. So I'm leaving my answer as this. Okay. Now, so this is how you do example number 4 using system of equation. Now, another way to do this is the following. I'm going to do it directly on paper. So I'm going to use this to help me too, because a lot of these equations will be the same. So what you do now, you want to find, because using enthalpy cycle is still the same thing, you want to find the enthalpy of hydrogenation of ethylene. So in this case, I'm going to write out this equation. C2H4 plus H2 gives me C2H6. Okay, I'm going to leave myself a lot of room. Now, the thing is this. If you look back at these equations, now the combustion of C2H4 is, it gives me carbon dioxide and water, right? 2 carbon dioxide and 2 water to be exact. So 2 carbon dioxide plus 2 water. Now, what I'm going to do on this arrow here, over this here, is the fact that it's like, oh yeah, you need 3 oxygen for that. And the delta H here is minus 1390. Okay? So essentially, it's this equation. I just wrote it this way. Now, combustion of hydrogen. Again, the equation gave you the heat of combustion for this. So in this case, I'm going to write it down here too, slightly slanted. So in this case, a heat of combustion of hydrogen, and we kind of have it here, 1 hydrogen plus half of oxygen gives you 1 water, 1 molecule. So plus 1/2 of O2, it gives me 1 water molecule, right? So in this case, delta H is here. This is minus 286 kilojoules. So, and if you look at this equation that we came up with, and that's the information that's provided, C2H6 plus 7.5, no, 7.5, 7 halves oxygen gives you 2 CO2 plus 3 H2O. So, in this case, C2H6, I'm right over here like this, kind of pointing to this whole blob, right? Pointing to this whole blob. So in this case here, plus 7 and 7 halves O2, and the delta H here is minus 1550 kilojoules, right? So that's kind of how I would write out the enthalpy cycle. Now, the thing is this. Because what you end up going to be doing is, I'm going to use, yellow is always horrible in the way in terms of highlighters. So what you're going to do is, because you want to find the reaction enthalpy going this way, but you cannot do it directly. So what you would do is you'll go this way, because if you go through this path, you have 2 carbon dioxide, 2 water molecules, plus 1 other molecule. So in this case, when you add these up, this whole thing up, and then they go from here backwards. So you kind of flip the sign. So this goes this way, you have to flip the sign. So what was minus becomes a plus. Okay? So in this case, you will go through this way. You have 2 carbon dioxide, 3 water molecule, go through this way to come up with C2H6. So your delta H in this case will be this here, minus 1390 plus minus 286, because you go through both this way, right? Now, because you're changing the sign, so you're going to be, you can say minus minus, or you just change the sign directly and just add plus 1550. Now, lo and behold, it's the same thing here. Okay? It's still minus 126 kilojoules. So, there you have it. Either way of solving this particular equation, enthalpy cycle or this, both will have the same answer. So, make sure you do a lot of practice. Now, normally you're not going to, for a question like this, you might not need to do, you can easily do this type of calculation if you want to, but you might have more complicated stuff where you're supposed to read the information from the cycle, enthalpy cycle, to do some other question. And I think on the In the study guide, I'm so messy. On the study guide, you will, on the page with Hess's law on the bottom, there's a complicated one where you would see that you might see something like that, but it's not that bad. The more practice you do, the better you'll be at it. Okay, so good luck on the review and have a good day. I don't know.